Saturn looks like the most peaceful planet in the solar system, but that image is a lie. The golden rings and soft clouds hide one of the most violent environments astronomers have ever studied. Beneath that calm surface, winds tear across the planet at 1,100 miles per hour. Storms larger than Earth rage for decades. The atmosphere becomes so dense and hot that it would crush and melt anything that tried to reach the bottom. So what exactly is Saturn hiding beneath those beautiful rings? Saturn's smooth pale surface looks peaceful because observers can't see what's happening underneath. The visible layer is made of ammonia ice crystals floating high in the atmosphere. These clouds move slowly and appear calm, but just below them, the real atmosphere begins. Temperature rises sharply, pressure increases, wind speeds climb to levels that would destroy any structure humans could build. The smooth appearance exists only because the chaos is hidden beneath a thin visual mask. What looks calm from millions of miles away can hide extreme violence. But if the surface is just a mask, what happens when you look deeper? What forces are actually driving Saturn's atmosphere? Saturn generates storms so large they can be seen from Earth through a telescope. The planet experiences regular great white spots, massive storm systems that appear roughly once every 30 years. These storms stretch across thousands of miles and last for months. Wind speeds inside them reach 1,100 miles per hour, nearly twice as fast as Neptune's winds, and far beyond anything on Earth. At Saturn's North Pole, a hexagonal jet stream creates a permanent hurricane larger than Earth itself. The storm rotates continuously, powered by heat rising from deep inside the planet. Scientists measured wind speeds there at over 300 miles per hour, and the feature has remained stable for decades. Saturn's storms are among the most violent in the solar system because the planet has no solid surface to slow them down. The energy driving these storms comes from Saturn's internal heat, not the sun, meaning they never run out of fuel. But violent storms are just one danger. What would actually happen if something tried to descend into Saturn's atmosphere? Saturn's gravity doesn't just pull objects toward it, it obliterates them. The planet's mass is 95 times greater than Earth's, creating a gravitational pull at its cloud tops that's slightly stronger than what we experience on Earth's surface. But the real danger isn't the gravity itself. It's what happens when something descends into the atmosphere. Any probe attempting to go deeper would face rapidly increasing pressure and temperature. At a depth of just 60 miles, atmospheric pressure reaches 1 bar, the same as sea level on Earth. Descend another 60 miles and pressure multiplies by 10. Continue downward, and within a few hundred miles, the pressure becomes thousands of times greater than anything on Earth's surface. The hydrogen gas becomes so compressed that it stops behaving like a gas and transitions into a liquid. Go deeper, and the liquid hydrogen is squeezed so tightly that electrons are ripped from atoms, turning the substance into a metallic hydrogen, a material that conducts electricity like metal but remains fluid. The atmosphere becomes progressively denser and hotter until it transitions into liquid, then into exotic states of matter that can't exist anywhere on Earth. Any probe sent into Saturn would be crushed, melted, and eventually vaporized long before reaching the core. The Cassini spacecraft was deliberately destroyed in Saturn's atmosphere in 2017 to avoid contaminating the moons, and it disintegrated in seconds. So if nothing can survive inside Saturn's atmosphere, what about the space around it? Is that any safer? Saturn's invisible dangers are just as lethal as the visible ones. The planet generates a powerful magnetic field that traps charged particles from the solar wind, creating radiation belts around the planet. These belts contain high-energy protons and electrons, moving at nearly the speed of light. Any spacecraft passing through these regions is bombarded with radiation that can destroy electronic components and degrade materials. Saturn's magnetic field is weaker than Jupiter's, but it's still strong enough to accelerate particles to dangerous energies. Enceladus, one of Saturn's moons, shoots water vapor into space, and this vapor becomes ionized by the magnetic field, creating a plasma torus around the planet. Spacecraft face constant risk near Saturn because the radiation environment is hostile and unpredictable. But radiation and crushing pressure are just surface-level dangers. What's actually happening at Saturn's core? Scientists still don't know what's at the center of Saturn. Models suggest the planet has a core made of rock and ice, but its exact size and composition remain uncertain. Surrounding the core is a thick layer of metallic hydrogen, a substance that doesn't exist naturally on Earth and can only be created in laboratory experiments under extreme pressure. This metallic hydrogen generates Saturn's magnetic field through convection currents, similar to how Earth's liquid iron core creates its field. Saturn also radiates more heat into space than it receives from the Sun, meaning the planet is still slowly contracting and releasing gravitational energy left over from its formation. The internal structure is so compressed and hot that normal physics begins to break down, and scientists must rely on theoretical models that can't be tested directly. Saturn remains scientifically unresolved because humans can't probe its interior. Without direct observations, theories about Saturn's core remain educated guesses. The planet defies easy understanding because the conditions inside are too extreme to replicate or observe. If Saturn's interior is this mysterious and dangerous, what about everything orbiting around it? Do the moons make things better or worse? Saturn isn't dangerous alone. Its system of moons makes the environment even more hostile. Titan, Saturn's largest moon, has a thick atmosphere and liquid methane lakes, making it one of the most interesting bodies in the solar system, but it also contributes to the hazards around Saturn by shedding particles into space. Enceladus shoots geysers of water vapor from cracks in its icy surface, and this vapor becomes part of Saturn's E-ring. The rings themselves are not peaceful. They're made of billions of ice chunks, ranging from dust-sized particles to house-sized boulders, all orbiting at thousands of miles per hour. Any spacecraft passing through the ring plane risks collision with debris moving at lethal speeds. The moons also create gravitational disturbances that affect orbital mechanics, making navigation around Saturn more complex than around any other planet except Jupiter. A mission to Saturn must account for radiation, debris, gravitational perturbations, and unpredictable particle environments all at once. The entire system functions as a gravitational and electromagnetic trap that makes every mission a carefully calculated gamble. With all these dangers combined, how do scientists even approach studying Saturn? And what does this planet reveal about the limits of exploration? Saturn doesn't just challenge spacecraft, it challenges everything scientists think they understand about planetary formation. The planet's internal heat source remains partially unexplained. Its magnetic field doesn't align with the rotation axis the way Earth's does, creating a near-perfect alignment that scientists can't fully account for. The hexagonal storm at the North Pole has no equivalent anywhere else in the solar system, and no single theory fully explains how it maintains its shape. Saturn's rings are much younger than the planet itself, possibly only a few 100 million years old, raising questions about where they came from. The planet's atmosphere displays chemical processes that don't occur in laboratory simulations. Every mission to Saturn raises more questions than it answers. Saturn is studied cautiously, not casually, because the planet resists simple explanations. It doesn't fit neatly into models of planetary science. The planet forces scientists to confront the limits of their understanding and accept that some mysteries may take decades or centuries to solve. So after everything revealed here, does Saturn's calm appearance still seem believable? Saturn still looks calm from Earth, and that's exactly why it's so dangerous. The planet's beauty hides supersonic winds, crushing gravity, deadly radiation, and storms that never end. Its core remains unknown. Its moons add layers of hazard. Its rings are a field of orbital shrapnel. Every aspect of Saturn is hostile to exploration, yet the planet appears serene in telescopes and photographs. The planet is one of the most hostile worlds in the solar system, not because it looks threatening, but because it doesn't. The calm exterior conceals violence on a scale that's difficult to comprehend. Saturn doesn't announce its dangers. It waits for observers to get close enough to realize what they're actually looking at.